on to 1.5, comparing indices. So the idea behind this is when you want to find the unknown index. Okay, given that your base is the same and your base has to be more than zero, it has to be positive. Okay, and it shouldn't be one because one to the power of any number here greater than zero will always be equals to one, right? So let's move on to, okay, try 16 is pretty easy. Let's do try 17. Try 17, you're supposed to find the value of x if 25 to the power of 3x plus 1 is equals to 1 over 1 to 5. So the idea here is that you must first convert the base such that the base has to be the same first, okay, and has to be a positive value. So over here, when you have 25, 3x plus 1 equals to, now 1 over 125 is actually just 125 to the power of negative 1. Okay, so let's see, how can we make this two to the same base? So if you practice enough, you will know that just the common base that they can go down to will be 5. So 25 is 5 squared. And for 125 is 5 to the power of 3. Okay, so now you can use the law of indices, and these two powers can multiply each other. So you have 5 to the power of 6x plus 2 is equal to 5 to the power of negative 3. Now, given that the base is the same, we can now proceed to compare the index, which means that 6x plus 2 is equal to negative 3. Okay, that will give you 6x is equal to negative 3 minus 2, and 6x is equal to negative 5. X is now negative 5 over 6. Right? Okay, now let's take a look at exercise 1.5. Again, I want to look at level 2 questions. Let's look at 2D. Okay, so for 2D, what we have is 3x is equal to 243 to the power of negative 1. So so let's find 243, change it to another base, and what you have is 3 to the power of x, oops, sorry, I did that wrong, 3 to the power of x is equal to 243 is 3 to the power of 5, okay, negative 1, so 3 to the power of x is equal to 3 to the power of negative 5, so by direct comparison, x is equal to negative 5, okay, and let's look at part E. Okay, let's do part E. So I was thinking it's a bit too easy. Okay, 32 to the power of 2x minus 1 is equal to 8 to the power of negative 1. The common base that you should go for would be base 2. So 32 will be 2 to the power of 4, sorry, to the power of 5. 2x minus 1 is equal to, this will be 2 to the power of 3. Okay, so please be careful that you do not confuse yourself. This is not 3 minus 1, this is 3 times negative 1. So you have 2 to the power of negative 3, okay, by the law of indices, you should multiply them. And then this is 2 to the power of 10x minus 5. So by the direct comparison, 10x minus 5 is equal to negative 3. 10x is equal to negative 3 plus 5. Okay, so 10x is equal to 2, and x is equal to 2 over 10, which is equal to 1 over 5. So we have. Now for the last one, 2f, 1000 to the power 1 plus 2x is equals to 0.1. Okay. So 0.1 is actually equals to 1 over 10. And 1000, okay, let's just leave it as 1000 first and we'll see, okay? 1 plus 2x. So let's think about what base you want. If you look at this side, this is actually 10 to the negative 1. Okay, I don't think this can go to a smaller base, so let's just say it's going to be a base 10. For 1000, it's going to be 10 to the power 3. Okay, so it will all be in base 10 now. And then this will be 10 to the power 3 plus 6x. 3 times 1 plus 2x is 3 plus 6x equals to 10 to the negative 1. So 3 plus 6x is equal to negative 1. 6x is equal to negative 1 minus 3. 6x, okay, 6x is equal to negative 4. So that means that x is equal to negative 2 over 3. So, question 3. Solve the following equation. So for 3a, I always forget to click this. Okay, so for 3a, we have, okay, for 4 and 8, you should know that you go immediately for those two. So 2 to the power 2 is not 2x, is equal to 2 power 3, 1 minus x. So this will give you 2 power 4x is equal to 2 to the power 3 minus 3x. Now let's compare the index. That will give you now plus 3x on both sides, 7x equals to 3, x equals to 3 over 7. So it's not difficult if you can recognize what is the base that you want. So for 27 and 81, the base you should go for is 3. So 27 is actually 3 cubed. 81 is equals to 3 to the power 4, right? So then you just, the whole process repeats itself.